There is a doubt in this question regarding the steps involved in solving this question. The reaction was hydrocarbon reacting with oxygen, forming CO2 and H2O. Applying principle of atom conservation. Principle of atom conservation means the total number of moles of atom on the reactant side will be equal to the total number of moles of atom on the product side. Now applying principle of atom conservation on oxygen atoms, the number of moles of oxygen atom on the reactant side will be equal to number of moles of oxygen atom on the product side. Now on the reactant side, oxygen gas contains oxygen, and on the product side, carbon dioxide and water contain oxygen. Molecular formula of oxygen gas is O2. As can be seen from the molecular formula, 1 mole of oxygen contains 2 moles of oxygen atom. So moles of oxygen divided by moles of oxygen atom will be equal to, if moles of oxygen is 1, then 1 mole of oxygen contains 2 moles of oxygen atom. So moles of oxygen is 1, then moles of oxygen atom will be 2. In 1 mole of oxygen, moles of oxygen atom will be 2. So moles of oxygen divided by moles of oxygen atom is equal to 1 by 2. Cross multiplying, moles of oxygen atom on the reactant side is equal to 2 into moles of oxygen. Similarly, for carbon dioxide, this is the molecular formula of carbon dioxide, that is CO2. 1 mole of carbon dioxide contains 2 moles of oxygen atom. So moles of carbon dioxide divided by moles of oxygen atom present in 1 mole of carbon dioxide will be equal to 1 by 2. That is, moles of carbon dioxide is 1 and moles of oxygen atom in 1 mole of carbon dioxide is 2. Cross multiplying, moles of oxygen atom will be equal to 2 into moles of carbon dioxide. Similarly, for H2O, from the molecular formula of H2O, 1 mole of H2O contains 1 mole of oxygen atom. So moles of H2O divided by moles of oxygen atom will be equal to 1 by 1. If moles of H2O is 1, then moles of oxygen atom according to the molecular formula in 1 mole of H2O is also 1. Cross multiplying, moles of oxygen is equal to 1 into moles of H2O. Now volume. Under similar conditions of temperature and pressure, the relative volumes are identical to the relative number of moles. Means, if volume of oxygen is Y milliliter, volume of carbon dioxide is Z milliliter. Then to convert this volume into moles, what is molar volume? Molar volume is the volume occupied by 1 mole of the substance, which is equal to 22.4 liters. So a volume has to be converted into number of moles. The number of moles is equal to volume divided by molar volume, that is 22.4 liters. So here if volume of oxygen has to be converted into number of moles of oxygen, then Y milliliter divided by 22.4 into 10 to the power 3 milliliter, unit has to be same, and this will give the number of moles of oxygen. And number of moles of carbon dioxide will be equal to Z milliliter divided by 22.4 into 10 to the power 3 milliliter. This will give the number of moles of carbon dioxide. Now the water formed is also in vapor state. So let the volume of water be W milliliter. So this is also getting divided by the molar volume, that is 22.4 into 10 to the power 3, so that it can be converted into number of moles. Now when you are equating the reactant side with the product side, then what happens? This volume term gets cancelled. Ultimately, instead of number of moles, you get the volume terms. So instead of writing the number of moles, under similar conditions of temperature and pressure, the relative volume are identical to the relative number of moles. So instead of writing number of moles, instead of dividing the volume by molar volume and changing it into number of moles, volume terms can also be used.